Hi, I'm Faiza Rizvi, Senior Associate Editor with Heart Energy, and I will be your host for today's webinar on subsurface cloud optimization and transformation. Now, seismic data is the heaviest data from where the oil and gas workflow starts, and there's been a tremendous amount of interest from the industry at large on what to do to really optimize the seismic data workflow. So we decided to bring together key technology companies to discuss and explore this topic and share some examples of how the industry is evolving. Now, I can tell you this is going to be a great session. We have an excellent lineup of speakers, and let me quickly introduce them to you. With us today is Mick Isernia, Head of Subsurface Solutions at Amazon Web Services. Also with us is Simon Kendall, CEO at Interica. We're also joined by Andy James, Chief Product Officer at Blueware, and our fourth panelist is Fabrice Bourand, Chief Commercial Officer at INT. Thank you, gentlemen, for joining us. We look forward to a great discussion. I'd also like to thank all our attendees who have tuned in this morning. Now, for some housekeeping rules real quick. As a reminder, all attendees are in listen-only mode. If you have any questions at any point during the discussion, please submit them using the chat feature, and the speakers will be more than happy to answer those during the Q&A session. Also, a recording of today's presentation will be shared after the webinar. So without further ado, let's begin the discussion with a brief round of introductions from the speakers themselves. Mick, would you like to start?
Hi, Faiza. Thank you. Yeah, this is Mick Isernia. I'm with AWS. My role at AWS is to lead what we call subsurface solutions, a part of the Energy IBU. My experience in oil and gas is about 20 years. I started with Hewlett-Packard and then Microsoft and NVIDIA, always in a role of kind of managing the ecosystem, the partner ecosystem in subsurface. And yeah, I'm similar role today at AWS.
Great. Andy, would you like to say a few words about yourself?
Yeah, thanks, Faiza. Hi, I'm Andy James. I'm the Chief Product Officer at Blueware. Blueware is a really innovative company that's been working with signal data such as seismic data. And over the last few years, we've been innovating workflows in the cloud. Really exciting place to be right now.
Great. Next up, we have Fabrice Bourand.
Yes, hi. Thank you, Faiza. In 1 minute, my name is Fabrice Bourand. I'm CCO at INT, which I joined 5 years ago to accompany the launch of our data visualization platform named iVibe. Been working in digital transformation for many years in various industries and focused more recently on the energy, which has picked up some steam over the past few years. At INT, we specialize in scientific data visualization. So we talk about large data set and geoscience data. So meaning, well, seismic or all the fun stuff. Glad to be here today.
Great. Simon, would you like to
Sorry, I have to unmute. I'm Simon Kendall. I'm the Chief Executive at Interica. I've started my life as a geoscientist and transferred across into data management after the last 20 years, with the view that data management could improve, streamline, and deliver great value to the energy industry. So that's my background, and I've been really on a cloud journey since about 2016 in terms of the transformation of our data sets in this industry.
Wonderful. Thank you all for the introductions. Let me now start with my first question, and this one's for Mick. Now, with the energy transition becoming a major focus for operators, what is Amazon Web Services' perspective on the geoscience portion of the workflow? And also, Mick, if you could tell us, where are you focusing your efforts?
All right, so as I said, I joined AWS about a year ago, and just before I joined, AWS decided to create an energy business unit. This indicates a very strategic focus from our company into energy, and energy includes the traditional oil and gas as well as new energies. So that's it's a very significant investment. We believe there is a strategic value for the planet, the overall energy market. In G&G, obviously, we don't build the G&G software or software for exploration and production and so on. All of our work is very much with partners. We see our focus as to build solutions to remove bottlenecks and increase efficiency for people in the workflow. Ultimately, the objective is to improve subsurface decision quality. That's what we see the ultimate objective. Seismic, from this perspective, is really key. Is one of the first data sets that is used to understand the subsurface. And interesting enough, while companies are kind of more focused in their exploration efforts with the changes in the industry, seismic data itself is going to become more complex, bigger, and more difficult to handle, but with a lot more richer of information. So it's going to have an impact on high performance computing, machine learning. OSDU, we know, is a big initiative around data that includes seismic as the first step. So that's a pretty important piece. The ecosystem itself is fundamental and is in full motion now. Cloud is becoming very strategic to many partners. That was not the case until a few years ago. OSDU has created a real drive for everybody as well. And so we see ISVs as fundamental for innovation and workflow acceleration, as I said. So there is a lot to be gained in starting the journey now. The journey is not necessarily the full OSDU, but even starting with seismic data, I think there is a significant return on investment for customer, and hopefully we'll be able to give some examples in the call today.
Excellent, excellent. Thank you, Mick. Now, it seems like the first step is the consolidation of E&P data, seismic in particular. Now, I'd like to know, and Simon, if you could answer this one, how can E&P companies manage to integrate cloud into their IT infrastructure, specifically in relation to seismic data?
Sure, thank you. As Mick has just said, we're happy to be part of the overall ecosystem, and it's those first steps that companies need to take. It is not necessarily an all or nothing step. And from our point of view, we look at developing a powerful and user-friendly data management platform that bridges the on-premise scenario with the cloud. Everyone has to take a journey, and in taking that journey, we are working with AWS. We're incorporating the work of OSDU, and we use rich metadata to deliver cost savings that are immediately available through the intelligent S3 tiering that we can manage with AWS. So really it's part of that journey and being a key part of that overall movement that's occurring in the industry today.
Great. Thanks, Simon. Now, if all E&P data can be consolidated and is now relatively easy to identify, now the remaining opportunity, I think, is to enable a data streaming model similar to what we experience every day with music, movies, and other data types. Now, Andy, Blueware has pioneered this technology. Can you please help us understand what it means? What does it take to enable this capability, and what value does it deliver?
Sure. It wasn't that long ago that we would go to the video store to rent a movie. And so we have this mindset of we always bring all of the data to what we want to do with it. And we bring that VHS tape home and we're putting it out VCR. But if you think about the way we watch TV today, it's completely transformed. We've got access to a massive online library of all of these streaming movies, TV series from the past, YouTube videos and how-tos and things. And we can access any part of that data at any particular time from any device that we want to. And so there's a huge opportunity to take that mindset and that approach to different data. And the cloud is enabling that. So using things like Object Store to store data in Amazon S3, and moving the library of your seismic data centrally into OSDU using formats like OpenVDS, we can have access to our entire library of seismic data, and that data can be delivered and converted so quickly with modern GPUs on the workstations that data can be served up into existing applications. So as Mick mentioned earlier about different formats, you don't need to worry about lots of different formats. You have one copy and that data can just be transcoded on the fly into formats such as Petrel, ZGY, PaleoScan formats and others within the industry as well. So it's really transformational and really enables digital transformations to become available today.
Right. Thank you, Andy, for that interesting insight. Now, at this point, I'd like to remind our attendees that if you have any questions, please submit them now using the chat window. So moving forward, if I understand correctly, all seismic data can be consolidated in OpenVDS, and all the existing applications can leverage this model today for seismic data. Mick, can you tell us how we can quantify the overall IT savings?
It's an interesting question because seismic data really touches very different places, right? So of course, it starts with acquisition. There is significant months that companies have to wait before they can actually get hold of the data that's been acquired. So there are opportunities to make the data available faster while the data is acquired, directly transferring to the cloud and enabling people to do QC and other early parts of the pre-processing, for example. That's an area there is significant value and is very much in terms of saving time or getting data early enough that you can have more time available to do part of the workflow. Then when you go into the more interpretation space that we're talking about today, it's interesting that for every file coming into the interpretation workflow, for every stack coming in 3D seismic, that file tends to be copied, duplicated, and converted to different formats, 15, 20, even hundreds of times, depending on the situation, how long the project is. So it's interesting that if you think about from that perspective, you have hundreds of copies over several months. And some of these copies are not just copying a file on your PC. We're talking terabyte scale files. Sometimes some of these operations can take hours. Sometimes it's something you start now and you come back the next day. So it's not trivial. It's a significant amount of time that all the geoscientists are investing or wasting, depending on how you see it. So in some way, an oil company invests in a geoscientist, and a significant part of this person time is actually invested on file operation. I think we can do better than that. That's a very important thing that we should probably take across in the conversation, right? Now, the other part is how much data, how much seismic data. When a company says, let's say I have 1 petabyte of seismic data, in reality, they have to over provision many, many times. So the data ends up being on tapes, sometimes is in archiving, and archiving has to be redundant, so usually 3 copies. Then there is a version, a part of the data is in HPC storage, another part of this data is interpretation storage. When you put it all together, we discovered that it's 5 times or more over provisioning. When you move this data in a cloud concept, first of all, redundancy is built in. So you don't have to think about redundancy. It's part of the fact that cloud data is automatically redundant. So you reduce all this over provisioning to a proper provisioning, and there is millions of dollars at stake just in terms of storage costs. I think the biggest value that I see is, again, the time and the efficiency of the people, and also the optimization of software licensing, because while people do file operation, they are actually locking an expensive software license doing that.
Right. Well, these are significant savings, Mick, and that should be very relevant to the industry today. Fabrice, like Blueware and Antarctica, INT has been one of the early supporters of OSDU and also an early adopter of OpenVDS. I'd like to know your thoughts on how you see a consolidated E&P data foundation delivering value to the workflow.
Sure. Well, as we know, one major frustration in the oil and gas industry for decades was the inability to break down silos and the lack of collaboration across domains with highly proprietary systems, at times strong in few areas and sometimes weak in others. So with the OSDU initiative, it's been the main driver to align operators and technology providers to create a common data ecosystem where interoperability is central. And about your question, the value in a consolidated E&P data is to enable complementary modern technology to be more agile, to be integrated, and to leverage best of breed capabilities, because we know that one size does not fit all. And in this ecosystem, I think what's compelling is we've all worked together to make sure that our respective system works seamlessly within the AWS OSDU data platform. And let me give you 3 examples. So the number one is that IVAP fully supports the OSDU seismic DDMS to visualize the seismic data. So it means you can see 2D, 3D traces, surveys, but also you can co-visualize that data with other type of data like wells and other data types. The second thing that we did, we supported, we made sure that IVAP support OpenVDS because it means performance for the end user and the ability to navigate through a large amount of data, which is very important when you go into the cloud, is the user experience and the efficiency. Then number three, we saw a need from operators to create IVAP ML process connector to connect and launch these ML and AI programs from various players like AWS SageMaker or Blueware Deep Learning to try to create this one continuity into the system. So in the analogy, I like the analogy that Andy talked about, streaming music or movies and how the industry has changed. Well, IVAP is like your music or video player, except in that case, this is your universal viewer for seismic data. And once the data is ingested in an OSDU data platform, cleansed, enriched, and managed, it becomes consumable by IVAP. So what it means for the user is it can access that data, it can start to visualize traces, do some QC, conduct data exploration, analyze, and once it finds the right data set, it can actually start to select it and put it to work with computation. And by launching ML and AI from various programs, like we were talking about deep learning from Blueware. So all this, you can do it from a single digital workspace. And that's what's important here is how the ecosystem can finally deliver a good user experience. I think Mick talked about the duplication, that the costs associated, but you have to think also from the user experience having to go in all the systems and manipulate that, and also deliver a true end-to-end workflow. So I think this offers, at the end of the day, a unique opportunity to reduce the processing time, the interpretation, modeling time, and general knowledge, actually, to extract data.
Excellent. Thank you, Fabrice, for that very interesting insight. Now, you just mentioned another buzzword, which is machine learning. Andy, if you can answer this one, I'd like to know how can OpenVDS and seismic streaming enable the application of AI machine learning to seismic data?
Yeah, sure. Definitely not a buzzword, though. I mean, the fact that you can go to your mobile phone and go to your image library and just do a search for something and it will bring up all of the images that have that object in. I mean, so these are mainstream features that are available today. So definitely not a buzzword. But in the most simplistic terms, an ML workflow can really determine whether a picture of a cat or a dog is actually a cat or a dog. And in order to achieve that, you need a massive amount of training data. And that training data is typically, hundreds of thousands of pictures of dogs and hundreds of thousands of pictures of cats. And then the network logic basically does all of the work for you. The process is really similar for seismic data, but instead of just little tiled pictures of cats and dogs, that data is broken up and represented as hundreds of thousands of small pieces of that overall seismic volume represented as small tiles. And these have to be pre-created and preloaded into tools such as TensorFlow, which really are mainstream deep learning engines. If data is stored inside OpenVDS, that data can be streamed directly into TensorFlow as opposed to pre-created as hundreds of thousands of images on disk. So it's extremely efficient. It can be extremely random, which is something you need for deep learning, and it can all be done on the fly, saving data preparation. The result is a really enhanced interactive workflow. And so we get much better results, we get more accuracy, we get to involve the geoscientist in the actual process of doing the training and the inference. And the results are faster, they're more accurate, and they're better. And when you get better results, you can do more, and you can interpret more, and you can reduce risk and uncertainty for what are hundreds of millions of dollars worth of drilling decisions by identifying information that could cause risk for drilling much earlier and more accurately.
Wonderful. Thank you, Andy. That surely sounds game-changing. Fabrice, can you now discuss some other examples of projects or use cases on your previous discussion, and how fast can a customer put together a POV?
Well, that's an interesting question. So we got challenged by one operator that wanted to actually test a little bit this integration. So we just conducted an interesting exercise with Halliburton in the past few weeks, where we used OSDU DDMS API to connect EDM to IVAP in just a couple of weeks. And the result was important because the idea was, once the EDM data is ingested into OSDU and registers, it becomes consumable by any other app in OSDU. And in that case, because of this connection, it was through IVAP, where actually a user can search and visualize the data from EDM and co-visualize it with any other data types. So I think it was an interesting practical exercise to demonstrate, how we can have systems talking to each other really rapidly.
Great, thank you, Fabrice. Now, it sounds like OSDU is enabling the industry to come together and collaborate better, and I think all four of you are testament to this. We'll now open the floor for questions. We'll hear from the audience. So if they have any questions, please send them using the chat feature, and the panelists will be more than happy to answer those. But while we're waiting for the audience to send in their questions, I actually have one for you, Mick, if you could answer this. As many operators are at different stages of uptake, and if I am a small operator with a lot of big seismic following in the wake of this technology boom, how would you advise that I find the right balance of on-prem storage and the offline global archive?
So I would say, just from my perspective, then we'll ask Simon to chime in, because they're a lot more involved with this portion of the workflow. From our perspective, we tend to see companies approaching this in two different ways. They either have an OSDU or big data movement connected to either the interpretation workflow itself, or processing, or machine learning. That could be an angle. Another one could be more specific project where they have evaluated things like the machine learning that Andy mentioned before, and they want to enable only that little piece, for example, to complement and augment their existing workflow. So it really depends. There are two kind of extremes. One could be just moving some small amount of data to automate some computation or machine learning. Another one could be a more broader project. But maybe Simon, as his company is a lot more involved with this part of the workflow, so I would like maybe him to comment further.
Thanks very much, Mick. Yeah, there's probably quite a bit to say in this sort of world. Seismic is one of the, if not the key data asset for every E&P company. And there's a long and rich history of it. So we know that in any company, these seismic data assets have a long life, and they have a very wide set of aspects to their usage. And what we do see is that as the adoption of the cloud is moving at different rates in different companies, there are opportunities as well as potential pitfalls as to how these new working practices are actually adopted. And to paraphrase one of my colleagues, he says, there is an opportunity here, but there is also an opportunity to create a new digital landfill. And really, it's the opportunity to not create the new digital landfill that maybe is the most exciting, so that we can move data into this new world. We can establish the metadata that identifies the provenance, the lineage, and everything we need to know about the data set. And that in doing that, we retain the visibility over the data, even if we are achieving the cost savings as we migrate things, for instance, into Glacier or Glacier Deep Archive, so that we can reduce the OPEX. Now, everyone focuses on the cost, but the cost perhaps, or the value proposition, is far greater. And by that, what I'm trying to say is that we're not looking just about the enterprise storage costs, but we're also looking at what we can do with the data, how we can better utilize it, and how we can realize value. And through the sorts of technologies that you've heard something about here, and Andy has talked about, and Fabrice have talked about, I'm most struck maybe by an example of one of our clients, one of our joint clients in here, who increased reserves on a single asset very markedly, not as a result of drilling another well, but of actually analyzing all the data, reinterpreting all the data, and understanding what the total reserve in a field was that enabled them to upgrade their resources and their reserves. And that fundamentally changes the value of a company. So I think that's really exciting. At the same time, we also talked about how SegWi was a standard. I'm not sure it was ever the standard. And we're seeing already that with OSDU and with the development of the different formats and standards, then we're getting away from a lot of those problems, which in terms removes all of the inhibitors of moving data between the different geoscience applications. And OSDU represents that advantage, that potential to have a single referenceable copy of the data with the full data lineage, and the need to have expensive and siloed corporate data repositories goes away. I'm also struck, yesterday I read the news, I saw that BHP is going to merge its assets in with Woodside, and you say, well, here's another example of energy transition, how different companies not only move data within their organization and move to OSDU for commercial advantage, but how companies need to move data between organizations so that they overall need to be able to take data and move it into and out of OSDU, and overall that we are working to shorten those cycle times and make the workflows much easier to operate in the current world. So maybe that's rather a longer answer than you were intending, Mick, and Faisal, I'll hand back to you to continue forward here a bit.
Sure, thank you, Simon. But before we move forward, Mick, if you could, just coming back again to the question where we talked about how customers can put together a POV, can you give us an example of how Amazon Web Services has worked in that field?
Yeah, so again, going more specific on what I said before, so let me use a couple of examples. We have maybe the simplest examples if where customers want to use some machine learning to augment their workflow. Their workflow is completely on-prem. So they are thinking, how do I enable data movement from on-prem to cloud securely, just for that specific data set or a small amount of data for a specific project. So we enable that securely. In the cloud, you will then be able to use machine learning, taking advantage of the scalability of the cloud. Everything happens pretty seamlessly from an end user perspective, because then the user will have like a local, it feels like a local application, but it's actually running in the cloud. So it does all the machine learning work. The results, when the results are done, the results are then securely moved back directly back on the on-prem. So that's a kind of, it's a loop that goes from on-prem to the cloud seamlessly from the end user, and is only to augment the workflow. A much bigger project is with a larger oil company where they already have, and it's in a very large data management platform they've built of their own, where they manage not only all their data, but also all the lineage inside their data. And so with them, we have a more broader OSDU project where we're moving some data intelligently, interrogating their data management platform, move it to the cloud securely, and enabling a workflow now of application that includes many of the well-known application packages out there. And in that example, we're actually using OpenVDS as the common data format, and FAST from Blueware to stream and transcode from the core, the central data, to the different applications. So that's an example. We're also, in that specific use case, we're also looking at how the streaming model could support much better dispersed asset teams. So teams that are sitting in very remote locations, and often oil companies have to duplicate the data to support their needs. In many cases, the streaming model can accommodate their needs by keeping the data centralized anyway. These are just a couple of examples.
Great, thank you, Mick, for that excellent insight. Andy, would you like to add a few examples from how your company is working here?
Sure, thank you. I've often heard the OSDU platform isn't mature, and my response to that is, well, it will be in about 20 years. I think the key thing is that there's a huge amount of value to be gained immediately from the data platform as it stands, and that value is going to just simply increase over time. Blueware has 3 key technologies that are available and work either as part of the data platform itself or as commercial applications that leverage data within the data platform. We've talked about it already, but OpenVDS is a core component of the OSDU data platform and is able to store all sorts of seismic data. And it overcomes the challenge of dealing with large data sets, such as seismic data in the cloud. It makes cost-effective use of storage platforms like Amazon's S3 storage, and then it supports true lossless compression as well. So it's a really cool way to have your data in the cloud and enable all of those streaming workflows as well. It's really kind of groundbreaking in terms of what you can do. The second technology is fast, and that's really the ability to stream data, as we talked about. We like to sort of talk about it as sort of the Netflix of seismic data. But that technology basically sits alongside your applications, delivering data directly into those applications without having to change the applications, enabling a central source for your data itself. And then the third solution is around deep learning. We have a product called Interactive AI that uses the machine learning techniques I mentioned earlier. And this, along with FAST, can be plugged directly into the OSDU data platform on AWS today.
Thank you, Andy. Simon, we'd like to hear from you now, and if you'd like to share any examples or use cases from Interica.
Sure. You know, I talked earlier about the move of assets, energy transition, and we see this as not only an ongoing process, but an increasing process. Mm-hmm. And if you're going to do that sort of thing, then there are a series of opportunities and challenges that are out there. And almost any time that a major company or an independent company sells an asset, there is a period of time in which the new owner has the ability to get their hands around all of the data associated with that asset. And that's generally within the sale and purchase agreement. And once that period of time has elapsed, then the opportunity is lost. So one of the things we've worked on a lot with AWS is the ability to undertake a data landscaping exercise, followed up very, very quickly with a migration acceleration process, so that you can see the overall data landscape. And one of the things that we're able to do is to look into all of the different geoscience applications. It continues to interest me that we see the same geoscience applications by name in different companies, but very often they have a very different workflow. So although you're dealing with the same series of applications, they're deployed in different ways for doing different things. And overall, you know, to give people a feel maybe of the opportunity, we worked with AWS on a purchase of a very large asset. It had a large number of fields, or a significant number of fields, a significant amount of production. And over a 10-week period with 3 different phases, we were able to undertake that landscaping, that data migration acceleration, and provide to the new owner a unique insight to the totality of the data sets and which data sets they really needed and which application data sets they needed to take on that new asset. So that gives you some sort of feel for how quickly you can start to deploy the technology and move into a cloud native working environment. So hopefully that gives people a feel for the sorts of things that can be achieved.
Thank you so much for that insight. We actually have a question here from, at this point, from one of our attendees who wants to know, for cloud optimization, how can 3D grid static dynamic reservoir models be used to help users improve their workflows? Mick, would you like to take this or direct this question to one of the panelists?
Can you repeat the question? I missed part of it. Can you try again?
Sure. Well, they want to know if in the cloud optimization, how can 3D grid, static or dynamic reservoir models be used to help users improve their workflows?
So it's very specific to application. I mean, the cloud itself doesn't really handle 3D grids. It's really related to software applications. So typically, if there are some limitation in handling that kind of data in some application, often is connected to the ability to access the proper hardware capabilities, often GPUs from NVIDIA of a certain size or a certain amount of memory, if the grid is bigger than a certain amount. In that case, the cloud, the contribution of the cloud in that situation is that you can choose pretty much ad hoc instances that are appropriate to the requirements of the specific task, instead of being limited by whatever the company has given you on your specific workstation. So that's in terms of visualization. Obviously, this also spills into the simulation part of grids. That is also another part where often inside all companies, individual reservoir engineers, either they do simulation on their own workstation, and there are of course limitation in performance on that, or they have to wait in a queue with other people waiting for when high performance computing clusters are available for that. That problem goes away in a cloud environment because of course there's unlimited capacity you can always tap into to run your simulation at will.
Perfect. Thank you, Mick. Our next question is actually from a geologist with some oil and gas background, and they'd like to know if one of you could please explain how a geologist with data science background can contribute in the overall cloud system through examples if possible.
Simon, do you want to take that?
Thanks, Mick. That sounds a bit like some of my background as a past geologist in my life. So I guess overall what we see specifically is that actually a lot of companies are moving towards self-service data management. So they're moving out of the world where the data management activity is in some way divorced from the overall operation, but they want to move to it becoming part of the geoscientist, the geologist's overall workflow. And I guess, you know, the things that are enabling a lot of that is the ability to have APIs, to script things, and to have Python. And that probably leads essentially back into Andy's world and Fabrice's world. But certainly the move into those sorts of knowledge base and technologies, I think, are going to be important for any geoscientist in the future.
Excellent.
I don't know if anyone else wants to comment at all.
Yeah,
sure.
maybe a quick comment from the user experiences. I think because the cloud bringing everything into one single place, you know, is removing the traditional 70% of the time dedicated to finding the data and moving the data and provisioning servers. You can change the user experience in focusing really on working and analyzing. And I think what we've seen is a huge need for collaboration. How do I expose to these data sets and this analysis? So in our case, it's through dashboarding and the ability to collaborate and to bring different teams that geographically are you know, decentralized, or maybe bridge, you know, right now you would see from one department sometimes to another, you know, a lot of compartmentalized way to analyze, and not that having those common points or common space where they can have the same view and talk about the same thing. It sounds very trivial, but I think that's what we see is going to change in terms of user experience. And to the previous question around maybe reservoir, and it touched about all the performances. I think the cloud has come a long way where we're trying to improve all the time, you know, the user experience. And there's a lot of strategy around, you know, compression, decompression, decimation, and other things where you can do to create really good experience and visualizing, navigating through all that data, 2D or 3D. So that would be just my additional comment to what Simon was talking about.
Good insight, Fabrice. Thank you. Our next question is about cost savings. Really, if you could please tell us, how can enterprises find the best cost model?
That's a pretty broad question. So I'll tell you how we approach this. So typically with customers, we do an in-depth analysis working with them. If they either work in a collaborative way with AWS, we have people that can go in and completely analyze not only the hardware, the infrastructure, networking, storage, and so on. And usually we can come up with a pretty compelling model, economical model that of course also help them move from a capital to a operating model. That's another important thing that the cloud brings. So they don't have to buy up front and invest for over 3 years with a typical 3-year cycle where you're stuck with a certain hardware for 3 years, and then you can get some new technology. You can have continuously the latest and greatest technology at your fingertips, and that's a significant advantage, especially for high performance computing and for very heavy applications like such the one that we have in oil and gas. They all tend to take advantage of NVIDIA GPUs, Intel CPUs, and large memories as much as you can give them typically. So in the cloud, you have that opportunity.
Right, thank you, Mick. Anybody else like to add to that?
Yeah, I think it's difficult to really truly analyze, but there's the pure costs and the IT costs that's sometimes a little bit more tangible, but you've got to also look at oil and gas companies they're doing more work with less people, and they're having to make some really significant decisions that have big consequences if they get them wrong. There's a lot of cost involved in some of those things. And if you can get more certainty into those decisions by using things like deep learning or interpret quicker, and those things add huge amounts of value to offset some of the perceived costs. And I think most oil and gas companies don't really have a good handle on what their current IT costs today. So it's kind of hard to compare in many ways. So it's difficult.
I would also add that COVID has added another dimension. Sorry, I'll give it to you, Simon, in a second. So COVID also opened up an interesting perspective. Some companies that were relying on traditional IT, centralized, and security really struggle to handle hundreds of people working from home, trying to keep working on their exploration, development, and production projects. So I think COVID opened up the eyes of everybody, not just in oil and gas, on what is the value of having a easier kind of cloud-based collaborative infrastructure. Simon.
Yeah, sorry, Mick. I think there are two aspects to the question in my head, and the first is that I'm not going to say simple, but it is a relatively simple. What is the storage cost? What's the enterprise storage cost for the data? And you can go through by doing the data landscaping work and stuff we've worked with AWS. You can get some very good handles on how far you can reduce that direct storage cost. There are then other questions about how do you take lots of data that maybe is sitting in tape in warehouses and never gets accessed, never gets used. Is that just a stranded asset, and how do you bring that into the cloud? But I think the real value proposition is that reduction in cycle times, that increased certainty of decision making. As I said before, if you can define the reserves better, if you can do those simulations using elastic cloud compute so that you're doing more and more simulations more quickly to increase the certainty of decision making, then that's probably the greatest value increment that you're going to achieve as a geoscientist working in an energy company. So I think there are the two aspects, the direct cost saving, but more importantly is the value creation and the reduction of cycle times. Maybe those are harder to actually quantify, but very significant. Sorry, Fabrice.
No, I love what you say, because I'm going to echo that a little bit differently. But just doing digital transformation, I think the answer is individual to each company, because the size of companies we're dealing with, it would be hard to say, okay, you're going to save 30% here randomly. So I think each company needs to do their homework. I think there's a cost of not doing it. which is measurable, because it becomes unmanageable. COVID has shown it quickly, but even before COVID, we saw some questions from operators which were not sure what they had bought, what they had acquired. They had issues also of people retiring and also the knowledge leaving the place, and have to fill that gap. So I think the real questions to the cost is obviously individual, and you have to build your cost justification to embark on that. But it's not just, if you look at it just from the cost perspective and not the value, as Simon mentioned, I think you miss probably the point. It's kind of a transition which had a lot of value over time, and make things manageable, and we're still running the operation. So not dodging the question, but I think it's individual to each customers and each operators.
Thank you for that insight. Well, moving forward with the questions, our next question from our audience says, how can centralizing data in the cloud make it easier for an operator to integrate technologies from multiple service companies?
Oh yeah, so I think that's a pretty significant value, because that's first of all, one thing that that we see quite often is there is a lot of companies with very innovative products. I mean, the one on the call with me today are three perfect examples. And sometimes for a business or an asset team to evaluate a new technology, they have a lot of internal barriers to be able to test some new software and so on. So that's something that the cloud makes very easy to do, for example. So that we have a marketplace for energy specifically for companies. So a customer that has a relationship with AWS can simply go to the marketplace, download possibly a demo license or a test license in agreement with the company, and they can immediately test it. So that's another example. Same thing for training. If you want to train people, often maybe the systems that are available inside the IT are not up to the specs required, maybe for machine learning or HPC or some heavy interpretation. You'll be able to pick whatever tool you want. And our effort from AWS, just in the example on this call, we're trying to bring the ecosystem together. Everybody has strength, and if you bring multiple parties together, the customer benefits, because now you get a best of breed approach. Instead of everybody trying to do everything and maybe doing two things great and the other things just because you have to, I see a future where everybody will really focus on what they can do, sit on an SDU foundation, for example, and the customer will be able to pick and choose best of breed. I think that's a real powerful model.
I think there's an additional aspect to that. Is if I'm pretty sure that every oil and gas company has a big box of data that they have from when they acquired a company or a set of assets from another company. And if all of that data over time made its way into something like the OSDU data platform, collaborating with a partner around a field is going to be a lot easier, because they can simply just connect people to that same data platform, as opposed to migrate data back and forth and move data around. So there's opportunities that haven't even presented themselves yet that will become more and more apparent with these open data standards and being able to deliver data through APIs to data scientists, to geologists, to interpretation applications.
Yeah, I absolutely agree with you there, Andy. And what we see is that reliance on tribal knowledge is something that is going away fast. And when you move assets, you don't necessarily move the people, and you need that ability to understand what you've got and disconnect the data from the applications. And that allows new ways of working. You can use the APIs, you can do very quick POCs to see if you can deliver further value. And I think that is just such an advantage that OSDU offers and working in the cloud offers. And it will just become the norm of the future.
If I use an example very fast, one of the OSDU projects we have is exactly to use it as a sharing secure platform in a joint venture in a specific asset. So that's something that should be relatively easy, even in traditional. Actually is not, because connecting the security of different oil company is definitely not an easy thing. It's a lot easier to have a common environment that everybody trusts with the right security, where you share only the data and application and other information that are appropriate for that specific asset team. Fabrice.
Yeah, I had just a quick comment is that I think all the players are well aware, including the services company. That's the model going forward. Just not to repeat exactly the same thing, but the example I gave is an expression of that, where Ali Burton, for instance, for the integration we created between EDM and IVAP was exactly addressing that point, which is now the services systems are becoming also consumable through SDU and open, this operability or interconnectivity between the systems that needs to talk. So I think this is the new way of working, which is taking gradually, shape. And as Andy mentioned, I think you don't need to wait for 20 years to start it when everything is in place. It's starting now. So you need to start incrementally, test, play with it, and gradually, start to drive value into that. And I think it's much more successful than the big bang approach. It's an iterative approach, incrementally bringing value that we've all worked together, I would say, to start now.
Excellent. Thank you, Fabrice. Well, one thing's for sure, I think your discussion has sparked a lot of interest among our audience because we're getting some really good questions. Our next question from our attendee is, how do you manage ownership of seismic data in a cloud environment? Is there a copy of the data per owner for multi-client data, or just one managed by an ownership system?
Yeah, so I'll make a comment and then maybe Simon has some additional comments on that. So the sharing of data is not just for seismic. That is something we do on a daily basis everywhere in our lives. So the example of maybe is not as critical, of course, in the case of a movie, but in case of bank accounts and so on, most banks are in the cloud. Most of our money is in the cloud on a daily basis. We connect to cloud-based systems. So that model of deciding what is shared and what's not, and what is allowed depending on user information, it's something that it's pretty well tested in many other industries, nothing really unique. Now, there may be something specific about, there are some uniqueness in the oil and gas. There are some countries where the data cannot be exported, for example, that make things, of course, specifically complex or unique, I would say. There could be subset of the data that sometimes are accessible to a user and not the full data set. So there may be more granularity, but from a technology standpoint, the cloud can accommodate all of that. Simon, do you have some additional comments on that?
Yeah, I guess, Mick, it's really all about permissions. It is about the right to see data. And I think inherent in the question is the fact that there are companies out there whose livelihood depends on the ownership of the data. And those are the non-exclusive seismic companies. And therefore, you need to manage those permissions very carefully. And in transactions, corporate transactions, one of the questions that comes back is, am I buying an asset or am I buying a company? The lineage of that data is important. The contractual basis behind the data is important. But it really is, there's nothing in it that is insurmountable. It could be very expensive if you get it wrong. And I'm aware of a couple of examples where it was got wrong and data was passed from one company to another where the permissions were wrongly assigned like that. But that is no more than a physical copy of the data. So really the management of the data in the cloud is all about the permissions and the lineage and understanding the origins of the data. So I think there's nothing inherent in cloud working that makes that a particular issue in its own right.
Right, Fabrice or Andy, do you have any comments?
Yes, I talked to a client at one point, and they were managing a library of seismic data that was expected to be shared with clients, and they had a situation where they had to bring the data down, bring it into a system, it was a huge data set, create a subset of that data, put that data onto a disk, and then ship it to the individual person. In a more modern environment, that is simply a case of streaming a subset and providing that endpoint to the user that can only get access to that subset of data. And all of that can be handled through a central library. You know, for instance, if you subscribe to HBO, you get access to the HBO library or something else. And it's really procedural, but how you handle it in terms of coding and the simplicity of it is much different. But it still does come back to permissions, and those things. Managing permissions doesn't go away. It's just how you deal with the permissions is what changes.
The only thing I'd like to add is that often this thinking about moving data is related to the fact that in traditional IT, you need to move data to get something done. So you need to move a file from the file server to the HPC group, or to instead in the cloud environment, when everything reads and writes through the same scalable storage architecture within our SDU foundation, you tap into compute, you tap into machine learning, you tap into visualization. It's not something you need to move. So, and with the streaming, that is extremely powerful as well.
Great, thank you, Mick. And now we're running out of time, so 3 minutes left. We'll just take one last question. So will accurate metadata help create a referenceable data set for a particular asset that can be quickly found and used in an application?
Simon, do you want to take that? Seems to be your
So it
space.
seems to be right up my street, doesn't it, Mick? I think accurate metadata is my lifeblood. So my answer to that would be absolutely. And if you can have that accurate metadata, if you associate it with the asset, if you associate it with the applications, then you've got the foundations to build upon. And really, I look at it as like the foundations to a building, that you can create that accurate metadata. And we have a sort of internal saying, which is about discovering what you've got, discovering all of the metadata, creating the rich metadata, then being able to analyze that rich metadata, and then being able to act upon it. And so for me, that's a fundamental part of doing good data management. It becomes more complex as time goes by because we have more and more applications. We have more and more data. You know, seismic data becomes more and more complex. We used to shoot 2D, we go to 3D, we go to MAS, we go to WAS. The complexity of the data itself may continue to increase, but the metadata is the thing that describes it and is absolutely fundamental to moving into OSDU, working in the cloud, and managing your data sets effectively. So you can see I feel fairly passionate about that.
Yeah, I think an interesting consideration is that we only have metadata for, let's say, well-curated data types. At the same time, there are tons of other data connected to a project, to a field, that are not properly tagged. Think about PDF files or all kind of other documents and images and scans. They have information that actually, using machine learning, optical recognition, new technology, you can automatically extract and then bring it together into the same data foundation. Now you can correlate all kind of data you didn't even know, or was very difficult for you to find because they were not digitized and properly tracked. So that's what the cloud opens in terms of opportunity with a common platform.
Thank you, Mick. Any final closing thoughts or comments from you, Fabrice?
No, very excited to be here. I think we're just at the beginning of it. So I think the next 5 years, 10 years, going to be even more exciting. So looking forward to it.
Excellent. Well, that brings us to the end of today's webinar. I think you all gave us some excellent in-depth insights on the subject. Well, I really enjoyed our discussion today, and I hope you all did too. Thank you all for joining us, and I hope you have a great rest of your day.
Thank you.
Thank you. Bye-bye.
Bye-bye.
Thank you. Bye.